part chemistry, acids and bases, part 5. Our last part of our last unit. Hallelujah. Can somebody give me an amen? All right, we are almost there. We're almost finished. Okay, so let's finish strong. Okay, so now we're going to get down to the nitty-gritty, the fun part. How do we actually calculate the pH? What is pH? We hear about pH balanced shampoos and pH in the pool and all these different things, but what is pH? Well, when we look at some of these different common substances, okay, you can see 1 molar, which is about your stomach, is a pH of 0, okay? And then lemon juice is somewhere between 2 and 3, okay? Tomato juice is somewhere down in here, okay? Coffee is around 5. Pure water is right at 7. Blood is barely above 7, around 7.2, okay? All the way coming down here to 1 molar NaOH is 14. The reality is that pH really can be more than 0 to 14. You can have negative pHs if you have a super strong acid. They have some super acids where the pH is down negative 18, negative 36. But those are rare and they're only made in the lab. And so generally speaking, the pH scale is 0 to 14. However, there are always some outliers. There's always going to be exceptions. So what is this thing? pH. Okay, so we here see all that. It's a scale. Well, it is a logarithmic scale. Now, you're going to learn in math, logarithms, it's all about base 10. 10, if I wanted to get the log of 1,000, that means 10 to what power is equal to 1,000? So we would know that x is equal to 3. So the log of 1,000 is 3. 10 to what power is equal to 1,000? When you're taking the log of a number, when we're taking the log of this H3O plus, we're saying 10 to what power is going to equal my pH. Okay? So, in doing that then, to solve, if we have to solve this, we have to take that anti-log or the inverse log to isolate H3O plus, and then do that simply, H3O plus is going to be 10 to the negative pH. Okay, so this, I talked about Kw being a humongously important equation. These 3 equations, well actually these 5 equations right here are super, super important. Okay, pH is the negative log of H3O plus. So if I know the H3O plus, I can get the pH. But if I know the pH, okay, I can get that H3O plus by going 10 to the negative pH. Okay, so you got to learn on your calculator. Make sure you know how to use that little caret, little hat thing, and be able to go use your exponents. Okay, again, you got to learn how to use your calculator. Now, POH is kind of like I don't know, it's the exact same scale for bases, but nobody knows about POH, and we only care about pH. But they're related. But POH is going to be the same thing. It's the negative log of the hydroxide ion concentration. That's what we just learned how to calculate in the previous video. Okay, and then the same thing, if I want to find the OH minus from the POH, is 10 to the negative POH. Now, pH and POH, you see, because we always have H plus and OH minus, and they're inversely proportional, pH and POH always equals 14. So if you know the pH, you can find the POH very simply. Just subtract from 14. If you know the POH, you can find the pH very easily from subtracting from 14. So calculating the pH. Now, it's just, the only hard part about this is making sure you know how to put in your calculator, okay? Because the equation itself just has two variables, and you'll know one of them, you just have to get the other one, okay? So let's look and see how do we do this. Now, this chart right here is, kind of gives me a headache, but a lot of people like it and use it and whatever, so it's going to be out there for you, but it kind of shows if we're going from pH to H plus, if you're going this way, you're going to use H plus as 10 to the negative pH, which is we just looked at. But if you're going from H plus to pH, you're going to take the negative log of the H plus. And they do the same thing over there for the OH minus, and then pH plus POH. So this has all of the equations, all your important equations, all 6 of them that you need to know, all kind of right there, kind of telling you what you need to do, what's your conversion factor going to be. hopefully that makes sense. You know, you want to keep this handy. It just, this has everything all in one place, or you can just kind of have these equations right here along with that KW equation. Okay, so I mean that's really, that's the equations that we have to use. We just need to practice that now. So if I have, what is the pH of an HCl solution is 2.54, so what's the POH? Well, pH plus POH equals 14, so I mean this is a super easy problem. You just subtract and you get 11.46. Okay, so the POH is 10.23, so what's the pH? Well, again, we just subtract from 14 and we get that. So if you know the pH, find in the POH, or if you know the POH, find in the pH. Very simple, just subtract from 14, this equation right there. Now, if we want to say, okay, then what is the H plus of a solution that has a pH of 5.43? Well, this is that left side of that little square thing that we just saw, the relationships, but I just showed you that H plus is always going to be 10 to the negative pH. So if I want to find H plus, and again remember, H plus, H3O plus are exactly the same thing, okay? So H plus is just going to be 10 to the negative 5.3, 5.4, negative 10, try this again, 10 to the negative 5.43. Now, you kind of have here on the calculator, so this is on the TI-30 calculator, you're going to go and you're going to hit the second function button and hit log, okay, which brings up 10 to the here, and then you just add in, everybody's calculator is going to be different on this one. You can really just use the caret, this thing right here on your calculator to do your exponents, but you're just going to be able to know how to put it in to your calculator. You're going to be expected to figure that out on your own, okay? So this works with one type of calculator, but everyone's different. So the whole key is that you just plug in 10 raised to this power and you ought to get this number. So practice with your calculator, see that you can plug this in to get that value. Okay, but it's super straightforward. H plus is always going to be 10 to the negative pH. On the other hand, if I know H plus is this, then to find the pH, I just take the negative log of that. So it just depends. You only have, again, two variables. You're given one, have to find the other. In this one, we know the H plus, so we just plug that in, and then again on your calculator, you're going to hit negative log, and then type in 3.56 EE 10 to the minus 4. So again, you're going to have to know how to put scientific notation in to your calculator. Probably need a parenthesis when you do that. The log automatically puts a parenthesis in there. Okay? But you need to be able to come up with this answer, 3.45. So again, learn how to use your calculator. Google it. Google on you put your type of calculator in, Google how to do scientific notation, and I guarantee there's got to be a video on there, because there's a video on Google about everything. Okay? Now, but what if we don't just say H plus concentration? What if we say, what is the pH of a 0.15 molar HClO4 solution? Well, I know that HClO4 is one of those 6 strong acids, which means it's going to ionize 100%, so it's going to break up into H plus and ClO4 minus. Well, since it's monoprotic, that means I only get one hydrogen for every one of these, which means that whatever this concentration is, my H plus concentration is going to be the same thing, just like we did with the NaOH on the previous video. So H plus is 0.15. So, I mean, if you're given the acid, we're only going to be dealing with strong acids. They ionize completely. You just need to know. Now, if this was H2SO4, we would have to multiply this by 2 to go. So the H plus would be 0.30. Okay? But since it's monoprotic, only one hydrogen, is whatever this is, you get that. Okay? There's only one diprotic strong acid, so H2SO4 is the only one you'd have to watch for that. Okay? So, but again, once I know that, then it's just simple. Just plug in negative log of 0.15, and it comes out to 0.824. All right, so that's it. What is the pH? Now, what if we have a base? What are the POH and pH of a 2.5 times 10 to the minus 2 molar NaOH solution? Now again, NaOH is monobasic. That means that there's only one OH. So whatever the NaOH concentration is, that's what this is. Now you don't have to show this work. You can just do that in your head, but you need to know, again, if it's monobasic, whatever this concentration is, my OH minus concentration is going to be the same thing. Then you just plug it in. Now there's an extra step when you need to find pH, because again, remember, nobody cares about pOH. We only want the pH of a solution. So, but with a base, it's the negative log of OH. You got to find the pOH first. So you just find the pOH, just plug it into our equation. The pOH is 1.6, okay? And then this is just kind of, again, on a calculator, how you plug it in. But to get the pH, then, you just have to subtract from 14. So the pH is 12.4. That's the one we care about. But again, notice that this NaOH is a strong base. Therefore, we expect the pH to be up closer to 14. So when you have a base, you're going to have to calculate the pOH first, just using this equation, and then subtract from 14 to find the pH. Monoprotic, monobasic substances, whatever the concentration is of the main compound, that's what my OH is going to be, and that's what my H plus is going to be. Now if I had a dibasic, let's say this was barium hydroxide, BaOH2, well then I'd have two OHs, so I'd multiply this by 2, and it'd be 5.0 times 10 to the minus 2, and that's what I would put in here if it was dibasic, okay? If there's two OHs, so it would be CaOH2 or SrOH2. And so if you have that, then you have to double it. But most of the time, we're going to be dealing with monobasic, monoprotic acids and bases, and you just plug it in, okay? And that's really all there is to it, okay? So you're going to need to go through, on the Google form, you can't put exponents. It doesn't let you. So it's really important you follow the directions on this. Okay, so enter it as 3.78 times 10e. That e is going to represent your exponents. That's like it's raising it, minus 5. That you don't have to put anything in. Notice there's a space in between the x, the times here on both sides. Okay, and so plug it in just like that if you want to get the correct answer on that Google form. Okay. Now, you need to be able to do all of this. This is one of the most challenging parts of the math and chemistry because logarithms just tend to give people headaches. But the reality is you just got to know what buttons to push on your calculator. You have those 6 equations. Just kind of use that and kind of go back and forth. We're going, here, what am I given? I'm given H3O plus and I'm given the pH. So I know the pH. I need the H3O plus. So find the equation that deals with that and you can do this. Okay? Y'all, that is it for chemistry. So study this, go through it if you need to, go back through it. I'll make sure you understand this completely. It's a very important chemistry concept. Again, if you have any questions, be sure to ask your teacher about that because you need to be able to do the math. And then lastly, I ask that you like this video and subscribe to my channel. And have an incredible summer. Go Jags.